Hello everyone, welcome back to MindMatrix Learning. Today I'm Sachin, going to talk about the solutions of machine learning portion from MCS Test 1 solution. So before talking about, let me just tell you about once again that we are having the giveaways. You must have seen the last video. If you have not seen that, please check out. And over here, gist of what exactly we'll be giving away is written over here. Check out that video, okay, which will be coming at the end of this video as well, just to see that what exactly we are giving away and what exactly is the criteria for that, though it is written over here also, but still, okay. And don't forget to join our Telegram channel, WhatsApp channel, to ask more doubts, to talk to us, to share your like if you need any kind of guidance regarding that, just join the groups, okay. So now let me just start with the problems we had. So I have not taken all the problems, I'll be very honest. So whatever solutions would be coming up, those are not basically all the problems we had in our test, but these are the problems which are either tricky or a little different or a little lengthy. So those are the questions only I have taken over here, okay. And I'll not be spoon feeding, as in what I mean is I'll not be moving from the start to the complete end point of giving you the solution, but I'll be giving you the idea, or in the process you might get the answer as well. But the idea is to just give you a thought process on how to think about the problem and to progress in that direction. If you need exactly the solution, or like there are a number of students who have solved these problems or who would be solving it, you can get that in the groups we are already having. The Telegram group or the WhatsApp channel is just for the update, but for the Telegram group I'm talking about. Okay, so let's get started with this problem. So if I talk about this problem, it's a simple and easy problem, but I know people get confused over here just because of one thing, which is I hope you just read through this problem and you'll get what exactly is my point. So what are the principal components in PCA? So I hope you know, in the PCA what we do is we are actually creating new set of features which are having high variance, okay. So we find out those kind of new features. So definitely we are not overall talking about the first two things, okay. These are definitely not the kind of answer we are actually looking for. Now the point is that, okay, I have got this, but what about these two answers? Which of these two is correct? The answer is this one is correct, and people might feel that, okay, this was the correct answer. Just because something related to highest variance is written, it doesn't mean it's the answer. Because see, we may get the same original features if we apply the what PC on that, provided if our data was like that, so that like it was already a kind of the normal to every other component we had, or basically the features were normal to each other, and then we are getting and those were like scattered properly along with that also. So in that case I might get applying PC the same set of features, but that is not always the case. So what we get is generally the new set of features, which are nothing but the linear combination of existing features, because those are constructed from the existing features using the linear combination. And apart from that, they have these highest variance, so we just pick up those in the decreasing level of variance along with that, okay. Now if I talk about that, so the newly created features are already having those like in the order of a kind of decreasing variance. So by default that is going to be the answer. So rarely this is the case that we are considering the original features, okay. It would always be it would always be, because if we are getting the same set of features, so that also came out to be through that process kind of a thing only. So that is the new access or the new features we are getting from the linear combination of original features applying PC. And applying PC, we are getting those in the order of variance. We talked about this, okay. So this was the answer. Now let me just move on to the next one, what we are having. So this is the problem. Like it's a simple problem, though it seems literally a difficult one. So what is being given is a neural network is given. We have let's suppose this is the input layer, okay. Then we have three hidden layers, H1, H2, H3, and then we are having the output over here I'm getting at this point, okay. Now the thing is that we are talking about training the data set of having like, which is having 10,000 samples. 64 is the batch size given. We are having 3 hidden layers as mentioned. We are having 128 neurons in each of these hidden layers mentioned. The forward pass takes 2 milliseconds per sample. This is important. Okay, how much time in seconds will be taken to complete one epoch of training? So there are some terms which are very important. The first thing is, what is the epoch? I hope you have the idea. If you don't have, it's okay. Now what is this batch we are talking about? Okay, so these are going to be two most important thing which will be highlighting over here. So if I talk about the epoch is basically, you know, like what should I say, one epoch. When we call you know, a complete training to be one epoch, when we have seen the entire data set once. Now, why do I say this epoch would be different? Because if I'm just passing it once, so why would it be taking, you know, different epoch or something like that? Like, just to give you the idea around over here, that what exactly is the epoch I'm talking about, and how this would vary for different kind of a batch size or kind of a thing. We have mini batch, we have batch, we have stochastic batch kind of a thing present there. So what exactly this when we are talking about? So the thing is, see, if I have 10,000 samples with me, I'll be dividing it into the batches. I'm just talking about this particular problem right now. So I'll be having first batch, second batch, third batch, and so on. I'll be having the last batch. Okay, so this is having 64. This is having 64 samples, 64. This might or might be, may or may not be having exactly 64 because it's being the last one. So what I'm saying is, one epoch would be complete when during the training I have completed the you know, like passing off all these batches. In that case, when I'll say that one epoch is complete. When would I say two epoch? When I have passed all of these batches twice. When three epoch? When I have passed all of three batches thrice. Okay, so it's like when we have seen the entire data set during the training. Entire means the training data I'm talking about, not the test and all. Okay, so training data, when it has seen, that is called as one epoch. Okay, and the batches, when we are clubbing some number of data points all together, just because the matrix multiplications are faster, and you know, like in deep neural networks or for simple machine learning also, like we have an advantage using the matrices. So over there we have just one extra dimension, which is calling batch, telling me how many data points we have. So it's for that particular purpose only we have this thing extra. Okay, so now we'll have a simple assumption over here that it's going to be linear. See, there is a difference over here. If I talk about if I pass a simple one data point, if I'm passing one sample through the neural network, that means this one, when I'm passing through this one data point, one sample, it was taking 2 millisecond. Okay, it is taking 2 millisecond. Now definitely if I'm combining it into a batch, I must be getting a kind of a, you know, like a better utilization. It should speed up a little bit, but right now, see, that is a little a different thing, that okay, what is the kind of a speed up we get over there. But right now we'll assume it is kind of a linear thing, that okay, whatever is for whatever is for one sample, we are when we are passing through the this neural network, whatever is the time taken, multiplied by the number of sample I'm passing, that would be giving me for that particular batch whatever were the number of data points there. That means if you want to know that for a batch, one batch, what is the forward pass time? Pass time. So it's going to be what? Simply your, like, how many data points you have? 64 in a batch, and for one sample it was 2 millisecond, which is 2 into 10 to the square minus 3. This is for one batch. Okay, right now it's clear to us. Now to get the final answer, what do I need? I need to know the total number of batches as well. And as I mentioned, the last batch may not be containing exactly 64 data points. So for that, you need to just find out this, the number of batches. If I want to find out, that would be simply 10,000 by 64, and I'm talking about the integer division. Okay, so this would be giving you, like, the seal of this would be giving you around 150. I guess I have this. It would be giving you 157, and the last batch may not be having the same, like, 64 data points. So to get these number of samples in last batch, it is going to be equal to, it's simply 10,000 minus just one less than this, 156, because I'm talking about what are the number of batches over here, just one before that, and what are the total number of sample over here. So you will get it as 16. So that means the last one you'll be having only 16 samples. Okay, this is clear up to this point, I hope. Okay, so we have gotten this idea that one batch would be taking this much time in the seconds, and in the last batch we have only 16 samples. Okay, if this is clear, now the answer is pretty much simple. It will not be taking much time for you to solve. Can I decrease the size of this? I don't know, like, I'm not liking it. I guess no idea over here, but it's okay. Okay, so what would be the final output? Answer would be, if I talk about that, it is going to be, so this is for the one batch. How many such batches we are having? 157 is the total batch. This is the 157th. So that means how many batches with 64 as the batch size? That is 156. So I'll be having 156 into 64 into 2 into 10 to the power minus 3 plus whatever the last batch. How much time would it take? It is having only, like, just one batch we are talking about there, which is having only 16 elements, and the time would be 2 into 10 to the power minus 3. If you solve it up, you'll be getting the answer as 20 seconds as the answer, and this is the final answer which we had in our set of answers in the test. Okay, so this was the exact answer you'll be getting after solving this. Okay, I hope this idea is clear. You could get this. Now let me move on to the next question. What we have, this is a simple question. I don't know, like, whether you have solved it or not, but still just part of some numerical, so I thought, like, let's have it. So if I talk about this, so we have already this, and if I talk about the solution of this kind of an equation, I hope you remember we have something like this already. A transpose A x is equal to, we have it in this form, A transpose B. You know, x is this one, B is this one. You need to just calculate, and this is already A. This is your A. Okay, so what would be your A transpose A? You can just find it out. Okay, what is your B? You know, just find this value, just find this particular multiplication. You'll be having direct answer as x1 is equal to something and x2 is equal to something. Okay, that is the simplest thing. Like, though you already know this, just a point over here, that how do you solve it. So this was the problem which was there in your test, and then the next problem, which is quite tricky, I just want to talk about that. This one was a really good problem. Okay, I really love this problem. So let's talk about this problem. This is the last problem in this video. So suppose you are given one-dimensional data x1 to x25. Okay, so that is being shown as well, that you have around 25 data points, and those are like a little divided into the 4 buckets. You can see one type in 0 to 25, and then 15 to 75, and the other type of data from 25 to 50 and from 75 to 100. Zeros are from 25 to 50 and 75 to 100, and the other being from 0 to 25 and 50 to 75. We can see that. Okay, and we have this one-dimensional data. Which of the modification can give you 100% training accuracy? And we are talking about hard margin support vector machine. Okay, and the approach we are going to use over here is not just applicable to SVM. It was literally a tricky problem, so you can use it for like a kind of logistic regression problem as well. Okay, so most of the time where you are actually looking for a kind of a decision boundary, okay, over there you can use this kind of a problem, okay, in most of the cases and machine learning problems or the algorithm you're having. So same can go for this logistic regression as well. So what would be the modification you'll be using for 100% training accuracy we are talking about? And this is the training data we are having right now, okay, assuming it. So one thing is centering the data. What does centering the data means? Centering the data would mean that, okay, right now we are having it from 0 to 100. Okay, let's calculate the center and then align it. So it would be like, I'll be having 0 over here and then I'll be having something over here, something over here. Would it really help us? The answer is no. It would still be a one-dimensional data where I would not know, like, okay, how should I divide it to get the classification that, okay, something like this is happening or like this is wrong. Okay, I can't do that. I need to, okay, erase all. So something like this I need, something like this. So if I can bucket it up like this, it would be a good idea. Basically, below this would be counted as one category and above this would be counted as a different class we are having. Okay, so centering is not really helping me. Does it really help if I add a feature that is 1 if x is less than equal to 50 or -1 if x is greater than 50? Let's look at this. This is interesting. Okay, so if I just talk about this, so you have something like this. So what I'm saying is, I guess I can't create lines over here. That is a little problem over here, but it's okay. So let's suppose this is the kind of a thing I'm having. This is the one, it is 1, this is -1, and the rest part is same. That means it started from 0, it went up to 100. Okay, what were there? So we had till 25, till 50, 75. Okay, we had this. So we have a crop. Okay, let me just do the bifurcation. 25, 50 and 75, something like this is there. So we have these crosses, like which is limited until this point. Okay, like let me just mark it with different color. Okay, let me mark this line as well, because we don't have any point on these lines, if you can see. Okay, and then we have let's suppose something like this. We had zeros over here, like in whatever you can see, like there are, I guess, less number of data points over there, but still, yeah. And if I'm talking about further like this, I'm saying that these are present over here like this. So again, like this, and some data points like this, 0 0 0 0 0 0 over here. So can you look at a decision boundary which would be very easy to draw over here? The answer is pretty much simple. It is this one. It is this decision boundary. Exactly this decision boundary. Can you see the elements over here would be of one class, element over here would be of another class? Amazing, isn't it? So yes, if I use this kind of a thing, it will be solving the problem. Okay, I'll be able to get a decision boundary which will be giving me 100% of the accuracy. What do I mean by 100% of the accuracy? That I'm not having any kind of exception cases where one of the data point of one class is lying in the region of other. So it's pretty much simple that what we got over here in this case. Okay, so the second option is definitely the correct one, no issue with that. Now let's look at the third one. Add a feature. So see, I'll be giving you more of these. So if you get into the exact feature creation and then trying out, okay, what exactly, whether we'll be getting this or not, it is a different, all of a different story. But we need to think a little intuitively or logically whether we are able to get to the point where we are getting these kind of decision boundary which will be giving me 100% accuracy or not. So if you can understand that logically and intuitively, the answer you'll be having, then it's not a very difficult problem. Then it's a simple problem we are having. Like last time also, I don't know whether you can recall or not. Last year also in one of the MCS tests, we had this question where the decision boundaries were getting created with the help of cos or sine function, because we had something like this. Just giving you the context over here, that we had plus 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 over here, then minus 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 over here, then again plus plus plus, and then again minus minus. So this was a kind of a thing which we had. So over there the decision boundary would be created with the help of a new feature which will be taking cos or sine of the existing feature. Okay, just giving you the context around that. And this is again a really brilliant question over that. So adding a feature xi square, so would that help? So just to give you the context in this case also, I'll just rub it off. I hope this particular part is clear to everyone. I'll just remove it, and I'll be giving you the intuitive idea. How does your x square graph looks like? So even if I don't draw any line, any axes mostly, so you know it is going to be like this. This is kind of a graph of your x square. So if you want to classify the data points, how you can do that? So for that you can just create a axis, like okay, it should be cutting like this or like this, whatever. Or if it's like this, then it's a different case, but I would like to just go by this one, just this case. So I can just have, you know, a decision boundary which can help me classify when the data points are like this, that only in this middle portion I'm having one data points, okay, or like over here, whatever, this is having one data points, and on the other side I have the other kind of classes or the data point from other class. If I talk about this, then you know your xi square would have really helped, okay, because it will be creating a kind of a decision boundary according to xi square. Okay, I know xi square is giving you a curve, you are looking for a line, that is most of the time you are thinking when you're talking about the hard SVM problem. But just think about in an extra dimensional case where xi square is nothing but it is giving you a new dimension, and when you go into that, you'll not be just looking at the curvy portion, it would come like a straight line in that case, okay, which will be able to help you finding out these decision boundaries. Okay, so you can see, so for an example in polynomial regression also, that is not a kind of what should I say, classification problem we are solving there. I'm just talking about that. If in logistic you use that, again you can get a complex boundaries related to that. So in a similar note, if I'm using xi square, it should be something like this. That means I must be having in middle one class and on the sides the same class. In that case, I can use the xi square. So this is not really helping me out. It is not really helping me out. Which one? This xi square. Now, what about the other one, the last one? Would it help? Let's just check out that. So it is telling me xi square and xi cube both. So that would be giving me a kind of a cubic function. So if you know by default, how does a cubic function look like? So I hope, let me just show you for just the xi x cube only. If this is 1, this is minus 1, I know it would be like this. It is like this. Okay, now depending upon how I make this cubic function by changing certain things, basically appending or basically multiplying it with something or do something over here, and it's a number of things, adding some constant, whatnot. Okay, if I can do all that, I can modify this shape to something like this as well. I hope you would agree. So this kind of a shape is not really difficult to find out. We can find out this kind of a shape very easily, or something like this also, we can get this as well. It is also not easy to find for us. Okay, this is going to infinity, this is going to infinity. Now over here, if I cut it like this, or basically I align it properly, you can see I can have one set of data points over here. I can have one set of data points over here, one over here which are just repeating these, and one over here which are just repeating these. So can you see we needed this kind of a decision boundary as well? Let me just show you. I hope you have gotten this context. This is the graph of x cube. Okay, and if I just change it up, basically x cube, simple one is like this. If I just change it up, it may be something like this: a of x cube, sorry, not this, I can't, let me just say a of x minus b cube. I'm just creating a simple one plus some constant. something like this, a general cubic function if I'm creating. Okay, or it can be something like this, ax cube plus bx square plus cx plus t, something like this. Okay, anyone, like you can just consider in terms of a simple expression or a detailed one, you can just use it. So you can definitely get this kind of a shape or this kind of a shape. If you have this, you can then use it to solve this particular problem. How? Let me just show you now. So I'll just delete this. By now you must be able to create this note of this. So what would be happening is, let me just show you this. So we already had this as 0, 25, 50, 75 and 100. Now if I talk about creating a decision boundary, what I need to do over here is just this. 0 to 25 I had one, 25 to 50 I had other, 50 to 75 I again had the same thing. So like you can just create any one, like you can multiply by minus. You just need to just play with this, a minus x minus b cube plus c, or with this expression ax cube plus bx square plus cx you are already having. Okay, x you already had in the feature, x square you are all again adding, x cube is also again something which you are adding. Okay, so you just need to create something like this. Oh, sorry, my bad. I need to just I need to remove all. So this is 50. What I need to do is this thing. So this is 25, this is 75. Over here I'll be having somewhere 100. Over here I'm having somewhere 0. So you can see all these data points which are lying over here, which are crosses, would be part of below this curve. Okay, below this curve. And all these zeros like this would be part of data points of a class which are lying above this curve. So like this we can have like a proper decision boundary, which is not at all what should I say, compromising at any data point lying in the proximity of or lying in the region of other class. We had a proper set of decision boundary over here in both the cases which we saw. So that's how we could get a kind of 100% training accuracy in this case as well. Okay, so this was a literally good question. I hope you could understand that, and then I gave you the context around the creation of the decision boundary using sine or cos function, which you have seen in the last year's MCS paper which we created. So I hope you learned it, you enjoyed the test as well. If you are someone who have not tried our test, make sure you are trying it. We still have 4 more tests left, and then like I told you, like we have the giveaways as well, and okay, like you'll be getting a chance to win any of these depending upon how consistently you perform. And the already, if I talk about like why we are giving away all of these things, is there are 2 reasons. We could see the response from the students with respect to the quality questions we are having. Most of the students are requesting as well to increase the number of tests, as you could see in one of the like the giveaway announcement video only. Okay, and yeah, so please try it out. It's a good practice, just getting the relevant question for gate just before your gate exam. It's a good idea, and that is for free. Okay, and you can also join our groups as mentioned. So this, the right one is the WhatsApp channel group, the left one is the Telegram group. You can join them up, and for more doubts you can just post your doubts into the Telegram group. We'll be there to assist you, help you, and we'll be having more videos with respect to the other type of questions from other subjects. So this was dedicated for the ML questions only, which were either tricky or a little lengthy or a little, what should I say, a good one. Okay, so that was all for that was all, guys. Thank you for watching out this video. I hope you loved it. See you in the next video. Bye bye, take care.